I'm Emanuel Sandner from the AIT Austrian Institute of Technology, and together with my colleague online, Alvaro Martinez, I'm going to present to you an overview of the vCare architecture and its scalability. We've already seen quite some things about vCare and also an introductory video by also Kideta, how it is set up, and this is then more the narrative way to it, I would say. So what can you expect here? I'm going to present to you a journey of a patient getting introduced to the vCare system, the integration with current clinical practices and how they are extended to the home setting, and finally the integration, interoperability with other systems and platforms. So at first, I'd like to introduce you to the 5 main concepts that make up vCare. First, we have the pathway modeler. This is a web-based tool used by clinicians to model their established clinical treatments for pathway templates. And these pathway templates can then be customized and assigned to patients. In this example here, on the left-hand side, you have a pathway for e-learning for the patient for the Parkinson's disease. On the right-hand side, for heart failure and medication intake support pathway. And what you can do here is in the white rectangular boxes, define actions and services that are triggered by the vCare system. And the round connecting parts are conditional cases, how the pathway should be executed. Next, we got the professional portal. Also previously, we heard about Kiola. The professional portal is the gateway for the clinicians to the vCare system. Therein, patients are registered, configured, care plans are assigned, etc. Next, we have the patient user interface. On the left-hand side, an Android application with the avatar. On the right-hand side, a readability game for cognitive games. Then we get a couple of sensors, a home-based presence sensor, a wristband, or a weight scale. And last but not least, the processing element of vCare. You can think of it as the brain, where all the data is gathered and processed, and reasonings are being done. These 5 elements are mainly describe the vCare system. And now I'd like to take you on a journey from a patient's point of view, how they get introduced to vCare. So after medical incidents that requires a rehabilitation, after the initial rehabilitation at a clinic, the patients would get introduced by a clinician, and after the initial assessment, the patient is registered and configured in the professional portal. After that, the patient is sent home, and a qualified technician comes by, installs the hardware and the software elements of vCare, and from that point onwards, the patient can use the vCare system. This journey can be broken down into 3 stages. The first stage is the treatment prescriptions, where the clinicians can define these pathway templates that are required for this for the patient. Then the patient is registered in the professional portal, and the pathways that were created can now be customized for these specific patients, where activities can be assigned on certain weekdays, certain periods, and certain intensities. Then at the home setting, as said before, we have the tablet with the avatar application. We have a set of rehabilitation applications for the rehabilitation games for cognitive and motor games. And we have a couple of sensors that are needed for contextual information from the patient. Then we can continue to the second stage for the initiation of the vCare activities. Here, the previously configured pathways and care plans for the patient are now fed into the vCare system. And from that point onwards, the vCare system knows about the patient, knows about the rehabilitation schedules, knows about the activities. And at home, once everything is set up, the devices at home start sending their data to the vCare system, and the patient can start interacting with the vCare application by voice input or by touch input. And the virtual coach through the Android application suggests now the different rehabilitation activities that are supposed to be executed by the patient. The results from these activities, the performances, are transmitted to the processing unit of vCare. And there, at stage 3, adaptations take place. Adaptations based on the user data, based on the performance. And these adaptations are also modeled in the pathways with specific elements. In this case here, there is an adjustment of the duration, the targeted heart rate for a specific activity that is defined by the clinicians. And once the pathway reaches this point, the processing unit can make these adjustments based on the user's performance. At the same time, the clinicians keep track of the rehabilitation progress through the professional portal, as the professional portal receives its information from the vCare system. Such information contain notes and notifications from the system for the clinicians, telemonitoring data like step count or heart rate, or questionnaire answers. All right, this is the journey. I hope you have a bit of a better overview of the different components that are available in vCare. And now I will hand over to my colleague Alvaro. He will get a little bit into the more detailed technical implementation, how this is realized.
Okay, hello, good morning, everybody. I hope you can hear me properly. So in this slide, you can see a simplified version of the vCare architecture. Colors here only indicate which work package produced this component, so it is not relevant for this presentation. It is important to stress that the vCare system is a myriad of services that some of them existed before even the vCare project started. So the efforts here were headed into integrating these services with a minimal adaptation or changes made to these existing services. To do so, we introduced this central service. If you advance next, Emmanuel, to the central broker, we use this broker using the MQTT protocol. This protocol is an IoT standard which is lightweight and can be integrated with any kind of devices, even devices with a very low processing capabilities like microcontrollers, which offers the connectivity of devices to vCare. All the time vCare was also modeled into topics. A topic is the structure that you can see at the bottom, is like an address, in a way that every piece of information can be traced back to a very specific patient. Additionally, the message is that we are sending across MQTT atomic, meaning that they carry only one piece of information each. This strategy allows us to create services that subscribe only to the information that they are interested in, so they don't need to receive everything that is broadcasted in the network. As depicted in the picture, also you can see that this architecture is distributed. So we have a cloud part where all the shared services are hosted, but we also have a edge part which is replicated at each of the patient's homes, which hold all the point of care devices and all the integration devices. Also in this architecture, you can see that we have integrated the security using the OAuth 2.0 standard. This standard allows us to issue some specific access tokens which restrict the access to the information that is flowing through MQTT. So we have very constrained security applied to everything. Okay, can you advance to the next slide, Manuel? Regarding scalability, as we can see in this figure, we can provide 4 levels or 4 different types of scalability and extensibility. The first one, next please, is to add new functionalities to vCare. And for functionality, we mean that we are adding a new service. Next, Emmanuel, please. Okay. We can do it 2 ways. Either we can create a new service which is native for vCare. So knowing this topic tree in MQTT that we mentioned before, a service can start consuming data and producing information also on the system. And the second way would be integrating an external third-party service. No, please go back. Emmanuel, go back, please, to the previous part. Okay, so we do it what we call the vCare as a Service API, and this is a REST API which essentially is transforming web interactions into MQTT interactions in the system, and is also applying all the security. The next level of integration, please next, Emmanuel, is the integration of new data sources. This could be new devices, or it could be also remote APIs like Fitbit, for example. So basically, we only need a client which is interfacing with a device or with that external API and transforming all the information into the formats that MQTT understands. And also, we need to define the topic tree in MQTT to make sure that we are not overwriting some important information. The third level of integration, next please, is extending the system to new customers. In this context, customer could be a new hospital or could be a rehabilitation clinic. So with this scalability, we can create like virtual copies of the system. We call it a virtual host because we are not creating new services, but we are configuring these services to provide new instances of the system itself. So the core components support the concept of multi-tenancy, what makes really simple to create these copies of the system. Finally, the fourth level, next please, is to provide a better performance for the system by adding new computation capabilities or new servers. We use a containerization technology called Docker, which allows us to provide different servers and configure them as a swarm. We can add these servers to the swarm as nodes, and from that moment on, we can move the services from one server to another in a very, very simple way. This also allows us to scale up some core components by defining clusters and redundancy. So we can, from that moment on, we can balance the traffic that is arriving to each of these services. Next slide, please. Finally, this is the last one. You can see here a list of some of the standards that we have used. This is not the complete list, but probably the most important ones. From left to side, we can see Bluetooth Low Energy, which is the technology that we use mostly for medical devices and for devices that are at the point of care, the house of the patient, and more specifically by some specification called the GATT profiles, which is something internal to the protocol, and most of the providers already provide devices with this kind of formatting. MQTT, which is the second technology, I already mentioned that, is the one that allows us to communicate everything in the system. The third one would be BPMN, which stands for Business Process Modeling Notation. My colleague Emmanuel also showed some example of this, is what we use to model the treatments into pathways. And to execute these pathways, we have to convert them to some resources in FHIR, which is the fifth element here in this presentation. This FHIR is a subproduct of HL7, a modeling language used in healthcare mainly. And well, as I mentioned, it allows us to execute these treatments and also do the adaptations also mentioned by Emmanuel. OAuth 2.0, I also mentioned, is the standard that we use to provide all the security. We also use some semantics around the system to model all the data that is flowing. We also use some different representation language like RDF, Turtle, or JSON-LD. Docker, I mentioned, this is the tool for managing all the infrastructure. But this is not the only one. We also use, for example, Karaf, which is a container to deploy services written in a Java standard called OSGI. And we use it basically for deploying all the coaching and motivational services. OpenAPI, which is a standard for REST APIs, which allow us to describe what APIs we have internally in the system, and provide also some debugging interface for that technicians can use for quick prototyping. And finally, we have these two IoT platforms, FireWire and Universal. FireWire is used mainly to keep track of very important pieces of information, specifically those that need to track the historic for querying later on by the services. And Universal, which helps us integrating devices at the point of care at the house, and also doing some pre-processing of that information before sending it to the system. That's all from my side. Thank you for your attention.